Okay, I'm going to go through paper 2, and the first question is about electric circuits. Define electric resistance of a wire. Well, we know that V is equal to IR in circumstances where Ohm's law holds, and so R is equal to V over I, and so we can say resistance is a ratio of voltage across, we just get rid of that weird mark that appeared because of my shirt. It's the ratio of voltage across a component to current through it. Okay. Using the following data, calculate the length of, I don't know what that means, wire required to make a resistor with resistance of 6 ohms. Length of conducting wire required to make a resistor. Okay, let's, oh, constantan. I've never even heard of that. But anyway, you don't need to know what that is. I don't. Calculate the length required for resistance. Well, we know that R is equal to resistivity times length over cross-sectional area. Is that right? I think so. And so we want a resistance of 6. So we want R, and we want to work at the length. So let's just rearrange it for L first. Here we go. L, therefore, is going to be equal to R A over rho, which is 6.0 times A, which is pi times 2.5 times 10 to the negative 5 all squared over rho, which is 5 times 10 to the negative 7. Where's my calculator? There it is. Okay, so we want 6 times pi times 2.5 times 10 to the power of negative 5 squared divided by 5 times 10 to the power of negative 7 gives us 0.023, or 2.3 times 10 to the negative 2. Okay, so that's equals 2.3 times 10 to the negative 2 meters. All right. Next question. 3 resistors, each of resistance 6 ohms, are arranged as shown, has an EMF of 12 volts and negligible internal resistance. Determine the total power supplied by the cell. Okay, so for this we need to figure out the current. For the current we need to work out the resistance. In fact, once we have the resistance, we don't actually need to work out the current. But anyway, let's work out the total resistance. R total is equal to, 6 plus 1 over 6 plus 1 over 6 inverse, which is equal to, that's 6 plus 2 over 6 inverse, which is 3. So that's 9 ohms. Okay, and V is equal to IR. And so I is equal to V over R. And P is equal to IV, which is equal to V squared over R. V we know is 12, V squared is 144 over 9, which gives us, let's get our calculator out again, C, 144 divided by 9 is 16 watts. Okay. The same resistors and cell are now arranged into a different circuit as shown. Why is the total power greater than for circuit C? Okay. R in question C was 6 plus 3 equals 9 ohms. R now is equal to 1 over 6 plus 1 over 6 plus 6, all inverse, which is equal to 1/6 plus 1/12, which is 3/12, which is 12 over 3, which is 4 ohms. And so as resistance is smaller, has decreased, the power will increase as shown by P is equal to V squared over R. V is constant.